Hi everyone, I'm Shubham. I'm a master teacher at Vedantu. We are discussing JEE Advanced 2021, Paper-1 Mathematics, and the question for this video is this. For any 3x3 matrix M, let M between two vertical lines denote the determinant of M. Let E be this matrix, P be this matrix, F be this matrix. If Q is a non-singular matrix of order 3x3, that means determinant of Q is not 0, then which of the following statements is or are true? There are 4 options. It is a multiple choice, multiple correct type question. Let's first consider option A. So here P is this. So what about P square? It becomes 1 0 0 0 0 1 0 1 0 times 1 0 0 0 0 1 0 1 0, and if you see it carefully, it's very simply 1 0 0. So what you do is 1 0 0 0 1 0 0 1 0 0 0 1. So that essentially means P square turns out to be identity matrix. That also means P is inverse of itself. Now what about F being equal to 𝑃𝐸𝑃? Let's explore what is 𝑃𝐸𝑃. So 𝑃𝐸𝑃 essentially is, so here you put P and here you put E, P. If you see carefully, it's essentially swapping of second and third row. Check it out. As you multiply, it's like swapping of second and third rows. So this essentially becomes 1 2 3 2 3 4 8 13 18 multiplied by P again. Now again, if you see carefully, it is swapping of, you may say, second and third column. Check it out. You get 1 3 2 1 3 2, and then when you take this row and multiply accordingly, you get 8 18 13, and then 2 4 3. So this essentially, if you see carefully, 1 3 2 8 18 13 2 4 3. So it essentially is F only. So that essentially means F is indeed 𝑃𝐸𝑃. So that essentially means A is correct. Now in B and C options, we are seeing talk about determinant. We want to talk about determinant. So what about determinant of E? And also then we'll talk about determinant of F because those terms are involved here. And determinant of P, clearly you can see determinant of P turns out to be, check it out, -1. So what about determinant of E? It becomes 1 2 3 2 3 4 8 13 18. Now to simplify my calculation, let me do R2 goes to R2 minus 2 R1 and R3 goes to R3 minus 8 R1, so as to create zeros. So 1 2 3, 2 times you subtract and 8 times you subtract. So you essentially get 8 20 minus 6. So if you see carefully, these two rows are proportional. Yeah, so that essentially means determinant of E is 0. Now what about determinant of F? Determinant of F is determinant of 𝑃𝐸𝑃. Why? Because F is equal to 𝑃𝐸𝑃. So this essentially is determinant of P multiplied by determinant of E multiplied by determinant of P. Essentially, since determinant of E is 0, it becomes 0. So that means determinant of E and determinant of F both are 0. So now let's explore option B and option C. If you see option C first, clearly left hand side is 0. Why? Because determinant of E and determinant of F anyway both are 0. So left hand side is 0, right hand side is 0, and 0 greater than 0 is false. So C is not correct. Now coming to B option, EQ plus PF Q inverse. So EQ plus PF. F you can write as what? 𝑃𝐸𝑃. So F you write as 𝑃𝐸𝑃 Q inverse. So this determinant is what we are looking for. So this essentially becomes, if you see carefully, EQ plus 𝑃𝑃, P square. P square is identity matrix, and any matrix multiplied by identity matrix is the matrix itself. So P square is identity matrix. So it essentially becomes EP Q inverse. Now this essentially will be 0. Why? Because you can write this as E times Q plus PQ inverse. Yeah, distributive property of you may say matrices. So here this essentially becomes determinant of E multiplied by determinant of Q plus PQ inverse. Now no matter what this determinant is, since determinant of E is 0, it will be 0. And what about right hand side? It is determinant of E multiplied by determinant of Q, which is 0. It is determinant of P multiplied by determinant of F multiplied by determinant of Q inverse. Now determinant of F is 0, so that means this also becomes 0. So 0 plus 0 is 0. Left hand side is 0, right hand side is 0. So they are equal indeed. Now coming to the D option, sum of diagonal elements of P inverse EP plus F is equal to the sum of diagonal entries of E plus P inverse FP. Here if you see carefully, P inverse is same as P. We have already established this. So it essentially becomes PEP plus F, and PEP from option 1, and that what we have got while exploring option 1, option A. So PEP is F only. So this essentially becomes 2F. Now what about E plus P inverse FP? P is indeed invertible, and in fact, since P inverse is P, you can write P as P inverse also. So what you have is E plus P inverse F P inverse. Now since PEP is F, if you if you multiply by P inverse post and pre-multiply, if you do that, P inverse P will become identity matrix, P inverse P will become identity matrix, and here what you will get is E equal to P inverse F P inverse. So here since P is P inverse only, P inverse F P inverse essentially is E. So what you get is E plus E 2E. Now clearly sum of diagonal elements, what you may say as trace, of E and F is same, 1 plus 3 plus 18, 1 plus 18 plus 3. And sum of diagonal elements of 2F will essentially be 2 times 1 plus 18 plus 3. And sum of diagonal elements of 2E essentially again will be 2 times 1 plus 3 plus 18, which is essentially the same. So that means D is also correct. A, B, D are the answers. Thanks for listening. Stay tuned for the next question.